Hello everyone, it's Steve Boda from Imperial Light and Magic, and in this video we're going to talk about servo animation and control for your droids. There are a number of different options for controlling servos within our droids. One thing I want to make very clear is that trying to control servos from directly within your sketch is a very bad idea. In this video we're going to talk about the Pololu Maestro range of boards. The Pololu Maestro is a dedicated servo control board. It comes in a variety of sizes, has very flexible software, includes features such as speed ramping and acceleration. It's well supported with Arduino and Pi libraries. It can handle a number of different servo voltages, and it's also daisy chainable. As far as the hardware required goes, we're going to need a microprocessor. Something like the Arduino Mega with the Padawan sketch installed and working is fine. We're going to need a Maestro board, be it the mini or the micro varieties. We're going to need some servos, obviously. We're going to need a way of talking to the board through Windows or Linux, although support for Mac is not good. We're going to need some jumper wires, and we're going to need a power supply. Connectivity to the board is actually fairly simple. We need some sort of power for the logic of the board itself, between 5 and 16 volts. We need some sort of servo power, and obviously check your servo specs for what that voltage should be. We also need a common ground to go between this board and our microprocessor, and we need a receive line. The transmit line is actually optional, and it can be used to provide feedback if you wish to your microprocessor. The mini Maestro boards allow you to jumper power, which means that the power that goes to your servos also supplies power to the data of the board itself. You don't need two different power supplies. If you wish to do this on a micro, you can simply solder a small wire to make that connection for you. I do strongly recommend you use a power supply solely for powering the servos and the Maestro board. That way you avoid the potential for brownouts on the other boards within your circuit. Data connectivity for a microprocessor is very straightforward. We're going to be using a Arduino Mega, which will support both hardware or software serial, and we just simply need to run a common ground. We need to run a cable from the transmit on the Arduino to the receive on the Maestro, and optionally we can have a receive on the Arduino going to the transmit on the Maestro. The Maestro Control Center software is very straightforward to use. Once you've installed the drivers and the software, you'd simply run the Maestro Control Center program and connect your mini Maestro or micro Maestro board up over USB. Once we've fired up the Control Center software, there are a few connections we need to make to the Maestro board itself. First of all, we need some sort of power, and we can do that either using the servo power inputs and then the jumper pin to get the data running, or we can run the data separately through its own power supply if we wish. We need a receive pin, which is going to come from the transmit on the Arduino board we're going to use in this particular instance. And we're also going to need some servos, and just bear in mind that the first channel is actually known as channel 0. Once you've made your connections, simply go back to the Maestro Control Center software, and where it says connected to, drop that down and you should see the serial number of your Maestro board. Then in the status tab, you can simply put a tick in the enabled box for the servos that you've installed and start moving the sliders around. You should notice that the servos move accordingly. If you wish to return to a specific place, you can actually type a number directly into the target box to go straight to that particular location. Under the Channel Settings tab, we can start to change things like the minimum and maximum values that our servos can move to. The range of movement by default is quite limited, but it's very simple to simply change the values in those minimum and maximum boxes, and you'll then notice that your servos move an awful lot more. Just ensure that you press Apply Settings for that change to take effect. Then you can return to the Status tab. And you'll notice that on the servos that you've changed, the minimum and maximum values change accordingly. If you wish to change the name of your servos to something a bit more meaningful, you can do this under the Channel Settings tab, but don't forget to press Apply Settings each time you make a change. When you return to the status tab, you can now see that the name of those servos has changed. You do need to enable them again, as every time you push apply settings, this box is unchecked. Next, we're going to move on to some rudimentary animation. The way that this works with the Control Center software is it builds a series of frames. Each frame dictates the position of a number of servos. You don't have to move them all at the same time, and you build up a number of frames into a sequence. In this example, I've moved the slider for the door right over to its minimum value and selected Save the Frame. Next, I'm moving the arm value, and again I'm saving the frame. Notice that the number on the frame increases. Now I'm dragging the hand across. I'm going to save that frame. Next, I'm going to move the hand all the way to the opposite side, save the frame. Back all the way to its extreme this way, save the frame. Back the other way again, save the frame. Back all the way again, save the frame. So what we're building up here is some sort of wave animation. And then what we're going to do is we're actually going to type the value in to return this to its center. Save the frame again. Next, we're going to do the same for the arm. We're going to type the value in to return it to its center. Save the frame. And then finally, we want the door to close behind it. So we type in the center value, save the frame. What this does is it builds a sequence, which we can see under the Sequence tab. All of the frames are here now. The sequence name by default is sequence 0. We can rename that if we wish to something a bit more meaningful. Then we can push play sequence and watch what happens on the actual servos. Now, once we've actually reviewed what happens with our servo movements, we may decide that we actually need to change the speed on some of these things. Now, unfortunately, my screen capture software didn't actually catch me changing the values of these boxes, but you can simply double click on one of the frames and then it allows you to change the duration between these. So what I'm doing here is I'm changing the speed for the wave part of this particular script down to 100 milliseconds instead of 500 milliseconds. What that means is that the actual way that that servo will move will be a lot quicker. Now, if we play the sequence, we can see the result. If we've made a mistake, we can simply double click on it again, change the value, and then test the sequence again by pressing play sequence. If we wish to add a new part of the animation into the sequence, perhaps we need to change the amount of throw, we can simply create a new frame and save that into the sequence and then move it around using the move up or move down buttons. Then we can simply delete the frame we don't need and test our sequence again. Up until this point, everything we've done has involved the PC actually telling the Maestro what to do. In order for us to be able to trigger the Maestro via something like the Padawan sketch, we need to actually upload a script onto the Maestro board. Now, in order to do this, it's very, very straightforward. First thing we have to do is to create our actual sequences. So don't forget, frames make sequences, and then sequences make scripts, or a script. I've created two sequences, one called door, arm, wave, and the other one called wave only. And as you can see, we can, at this point, still go and have a look at each of the scripts, have a look at the frames, and make our adjustments. Once we're happy that the frames and the scripts are correct, the sequences are correct, beg your pardon, we're going to create a script. Now, as you'll see, the script tab is currently empty. If you've already got stuff in the script tab, it's a good idea to just clear that first, just click in it and delete everything that's there first. And then we're going to copy all sequences to script. This will take us over to the script tab, and as we can see, our door, arm, wave script is there, and our wave only script is also here. Now, at the moment, still this hasn't been pushed up to the actual Maestro board itself, and to do that, we click on the Apply Settings button. Now that our script has been applied up to the actual Maestro itself, we can now start to look at the actual changes we need to make onto our Padawan 360 sketch. The Padawan 360 sketch by Dan Kraus is a lovely piece of coding, and we have to tread very carefully in here so that we don't break anything. Fortunately, there's not that many lines we're actually going to put in. The first thing we're going to do is include the Pololu Maestro library. I'm also going to include the software serial library, and then I'm going to create a software serial instance called Maestro serial 10,11, and this means that we're actually going to be transmitting on pin 11, and if we wish to receive back from the Maestro, we would use pin 10. I'm going to create a mini Maestro instance called Maestro serial 3. Now that's actually a hardware serial port, so that's basically saying that there is something called Maestro, and it's going to be talking directly through serial 3. And also creating another one just for the purposes of this demo called Maestro S serial for software serial, and that will create as a software serial port, which, as we've already just declared above, will be trying to transmit on pin 11. All of those includes go above your void setup somewhere. Now, within our void setup, we want to begin serial 3, which is the hardware port, and we've told that to start at 9600 baud, which is the speed. And we're also going to start Maestro serial at 9600, which is our software serial version. So really, just for the purposes of this demo, I'm actually going to be using 2 different ports on the Mega to show you that you can still transmit serial and command your Maestro what to do. The way that the Dan Kraus system works is it's listening for key combinations. And as you can see in this first example, I'm actually going to use software serial. And what it's actually going to do is it's going around in a loop, and it's looking for a combination of the R2 button, which is the right trigger button, and it says, so the curly bracket there means and something else is coming, and also if the get button press of up, which is like the hat switch on the left hand side. So basically you have to hold R2 and up, that's your key combination. If you do both of those things, it's going to say Maestro serial, or Maestro S serial I should say, restart script 3. Now off camera I actually created scripts 3 and 4, and that's just so we can have some demos of different sort of scripts running. Also, I've just put some serial print LNs in here so you can actually monitor this with your serial interface, although you absolutely don't need to do that when you've actually pressed that key combo. It was just for testing. So that's us using a software serial to produce one of our actual events, and as I say, that's going to run script number 3. Now, don't forget, it starts at script 0, so that's actually the 4th one that we've programmed. Moving down in the script a little bit, the next one I've created is actually using hardware serial. So I don't have to tell it that it's software serial on this particular one. We're just going to say maestro.restart script 0, and that's on a combination of L, can't quite see what it says on my screen there, L2 and up. So this time, if you hold the left trigger down and push up, you will get script 0, which will run animation number 0. It doesn't matter what you actually call them when you were creating them. The Maestro itself only ever refers to them as 0, 1, 2, 3, 4, etc., etc. So also what we've done here is L2 and down will start script number 1, I beg your pardon. L2 and left will start script number 2, and L2 and right will start script number 3. So as I say, we've got scripts 0, 1, 2, and 3, which gives us a total of 4, slightly confusingly. So let's go and have a look at what that actually does on our servos. Okay, so for our first demo, we have actually got a wire plugged into serial port 3. So that's a hardware serial port, and that's the transmit port on the Arduino Mega. We've got our controller connected to it, and our 3 servos just sitting there. So what will happen now is this will trigger the hardware serial ones, which if you recall were on the left trigger. So if I now do left and up,
there's our open the door, open the arm, wave the hand, close the door. If I now push down with the left trigger, so I've got left trigger down and I now push down, I get one of the new sequences I created. If I go to the right, I will get sequence 2. And if I go to the left, I will get sequence 3. Oops, sorry, no, I tapped up by accident, sorry. So that's one of the new ones I created off camera. Now, if I do the right trigger and press up, which we programmed as one of our software serial things, nothing will happen. And that's because we're still using the hardware serial port on the actual Mega itself. So none of these key combos will do anything at all at the moment. So what we're going to do is we're going to pop that out of serial 3. We're going to come over to pin 11. So this is 8, 9, 10, 11. So that's now software serial. And if we're lucky, we now get our right key combo, which is still running one of the other scripts. We could obviously have made it run whatever script we want, and it could have been whichever servo on a different set of pins. So you don't have to sort of obviously use the same servos in each script, not at all. Okay, let's go back.
So as we saw in that demonstration, it's very straightforward to have both hardware and software serial ports working at the same time. So obviously this is something you need to take into account. You may well end up having to use software serial if you are running 3 hardware serial devices already, for example, but it is very easy to do. Also, just a couple of other things to point out. One of the common things is, well, I want my droid to actually play some sounds at the same time that it's doing the servo movements. And that's very straightforward. Wherever you've got your if statements for reading the button presses you want to do, once you've said to restart your script or before, just simply put in your mp3 trigger.play and then whichever track you want to play. If you're finding that you've got some issues with the timing of this, so you perhaps want the sound to start a few seconds after the servos start to move, so say maybe like an electro cattle prod kind of sound effect, but that can only trigger after the arm has come up, please do not use delays in this script. It will absolutely mess up the rest of your control system. In that sort of circumstance, what I'd perhaps recommend is editing your sound file and just putting a delay just of silence at the beginning of your sound file for whatever the length of time is that you want it to do. If you've got something the opposite and you want to play the sound first and then have a slight delay before the actual servos start to move, then I would suggest you do that within the actual Maestro control center software. Just simply up the time for the first servo move. You saw by default it was 500 milliseconds. Well, just simply change that to be whatever time period you want. There's a few considerations to be aware of. Speed and acceleration is globally applied if you just simply change the speed ramping or the acceleration. Now, we haven't touched on that as part of this particular video because I want to get this out without too much advanced sort of features of what we're doing today. What we're doing is advanced enough for people, and I don't want to start to confuse things. But if you want to start playing around with the speed and acceleration, then editing this you can do in the actual script after the event. Also, the Arduino Uno doesn't like supporting 3 software serials. It's fine with 2, so your Siren 10 and your Sabertooth 2x32 run actually over software serial, and your by default the hardware serial is used by the SparkFun MP3 player. I've had some challenges trying to get it working on 3, so honestly, for the time being, I would just simply recommend that you use a Mega. Sound events, as we've mentioned, can be commanded at the same time. You just simply put it inside the key combo that then does the restart script. And likewise, if you've got an existing key combo that, or even just a single key press like the A button or the B button, and you want it to do a particular script, then you just simply add the line saying Maestro restart script, and then whichever the script number is in there. Padawan isn't the only system, and not necessarily the best system either, but it is a great system for ergonomics and ease of actually being able to do stuff like this. But servo animation can also be done by some of the other systems such as Kyber and Shadow, and basically anything that involves having an Arduino triggered by whichever way you want to do it. The final thing I want to mention is that I've been experimenting with some digital servos, and I found just some slightly weird results where there seemed to be a slight delay between the moves. So on the servos I've used in this demo video, they're just cheap MG90 servos, and they work absolutely great. When I've used higher end digital servos, there seemed to be almost a fraction of a delay. If I told two servos to move at the same time, that those two servos actually moved. One moved a fraction, a hundredth of a second after the other one, when they should have sort of moved instantly at the same time. Anyway, that's about it. So there's a couple of links for you. Dan Krause's GitHub, I would strongly encourage you to go and give Dan some love. He's an absolute legend for writing this in the first place. If you'd like to get hold of the actual files that form part of this video and presentation, then that's where you can go and get them. Thanks for listening, and I'll speak to you all very soon. Take care for now. Bye-bye.